aspects of MySQL, such as containers. The photo on the right there above shows me discussing containers at the Microservices World Conference last October in Santa Clara. I also love doing exploratory testing of our distributed database solutions. As the American novelist F. Scott Fitzgerald once said, the chief aim in life is to avoid boredom, and one of the goals of this talk is to keep you from being bored. Here you see a photo of Jimmy Stewart from the movie Rear Window, which was created in the 1950s, directed by Alfred Hitchcock. Jimmy Stewart was doing exploratory testing of his hypothesis to see if the guy across the way from his window in his apartment murdered his wife. Exploratory testing is not only creating test cases in an ad hoc manner, but also it is a way to discover big ideas at a high level. The focus of exploratory testing is more on testing as a thinking activity. In this talk, I'll show you various testing techniques to help your organization determine which replication strategy and high availability solutions might be right for you. There's also a story here. I set up to discover the best replication for you using our latest tools. While testing, I had some questions since I couldn't set things up, or so I thought, in the way I wanted to. I contacted one of the developers who had written some blogs. He let me know that I could set it up the way I wanted. But the docs weren't clear on this, or at least they weren't clear to me to set it up the way I wanted to. So by exploratory testing and thinking from the user's point of view, I was able to set up replication exactly how I wanted to do. Each time you see the Jimmy Stewart binocular icon above in the presentation, it indicates exploratory testing that I've done with MySQL replication. This is a safe harbor statement by Oracle. It's found in most Oracle presentations. Please take a few seconds to read it. Here's the agenda for today. First, we'll talk about basic MySQL replication. Then we'll talk about master-slave replication with manual failover. And for number 2, I'm tempted to call it master replica replication, but it does seem that master-slave is the more common term in the MySQL literature. So our third topic will be InnoDB cluster with automatic failover. So that's a big improvement for you to have automatic failover. Number 4 is InnoDB cluster with multi-master replication. And then the last topic, 5, is good things to read. I'll leave you with some links in the presentation that you should be able to download. Please ask questions in the Q&A box as we meander through the slides, and I'll leave about 5 minutes at the end of the presentation for questions. Everyone requires their most critical systems to be available, and not only available, but highly available, 24/7, and depending on your culture, it could be 360 through 365 days of the year. So every customer I talk to, I've talked with a number of customers, and most of our customers do have some kind of high availability. So this is very important. No downtime. What is the cost and impact of downtime? Obviously, it's revenue loss, but you can damage your brand image. Impact to customer relationship. Trust is a really important factor in your relationship to your customer, and having downtime can really impact that. Loss in employee productivity. Any loss in employee productivity means employees are no longer creating new solutions, which can give you more business advantages. And we have more regulations these days, and you could have potential regulatory issues if you have downtime. What is replication used for? It's a major building block for high availability. And here in this diagram, we have server A, B, and C, where A is your master. Okay, things are humming along quite well, and then suddenly, you have a crash with your master, and you're only left with your 2 slaves. But everything is okay after the crash. The DBA manually handles the node failure and moves the application to the new node master, which is B. Many customers use MySql replication for this. Facebook, Twitter, Booking.com, Tesla, Airbnb, as well as other companies that have been in existence for over 20 years. The benefit of MySql replication is not only for high availability, but it also leads to faster queries. So the master receives both writes and reads, and the slave receives only reads. A big contributor to the wide adoption of MySql is the simple yet elegant methods that are coded to set up replication. Master-slave replication gives us the ability to mirror a database to one or more slaves, or many databases to one or more slaves. This method scales out. In fact, I'm wearing a t-shirt right now that says, "Don't worry, keep calm and just scale out." So this scaling out works. You can direct your queries to send reads to the slaves and writes to the master. You can back up each slave and put it in another location, giving you one of your more important requirements, which is a disaster recovery plan. Each slave can be a database representing a customer or region. I call it logical sharding, or breaking things up into pieces by databases. You can have a router that acts as a load balancer to distribute queries to slaves. Each slave can also be used as a backup, although you should back up your databases. And here we see a little icon, which is the pen with the paper and sunglasses on the master showing read writes, and then the slaves have the reads only. So the second thing we're going to talk about today is master-slave replication with manual failover. So how do you failover with MySql replication? We have one master in the middle and two slaves, A and B. And we have a connector. And here we see we have a problem with the X there. It shows that the master has crashed. So what do you do in this case? Manually, you have to check the binary logs where the transactions goes on the master. You can see we have 4 different transactions here. You have to check the relay logs. Those are the logs sent to the slaves that show these transactions. And you compare those to the binary logs. And notice that they've gotten a little bit behind, the two slaves. Slave A has position 10 and 11, where slave B is missing the last transaction. Okay, we've checked the relay logs and compared with binary logs, so now we have to apply the missing transactions to the slave. So on the left, we apply transactions 12 and 13 to slave A, and on slave B, we apply transaction 13. We now have to stop the slave on both MySql instances. And again, we're doing all of this manually. And now we have to enable binary logging on slave A and restart it. These are 5 steps that we have to do manually. And now we make slave A the master. And now we configure the application to point to the new master, which is formerly A over here. So to perform manual failover with basic MySql replication, it's a manual process. You have to go through all the binary logs to get the slaves in sync. However, with manual replication, you know what's going on. Many MySql customers perform manual failover. If a master fails, whether it is in the middle of the night or during the day, the MySql engineer has to remedy this situation. The engineer has to fix the server that crashed or add another server to the replication set. In addition to the steps above, the engineer has to then determine why the crash happened and if there's anything to do to prevent it in the future. Again, type your questions in the Q&A box, and I'll try to answer them. Manual failover is a tested and sure method. With manual failover, you as a DBA knows what's going on. That's a blessing. You know what's going on and you can fix your issue, but lots of people don't want to be awakened in the middle of the night to do manual failover. They want the failover to happen without manual steps. In other words, they want to sleep soundly. For that and many other reasons, we have the InnoDB cluster in its single primary mode, and this provides automatic failover. We'll talk more about single primary mode in a couple of minutes. What is the MySQL InnoDB cluster? It's a single product, MySQL, with high availability and scaling feature baked in. It provides an integrated end-to-end solution that is easy to use. I think this is a good definition to start with. What are the use cases for MySQL InnoDB cluster? The first one is elastic flexibility. This is where your infrastructure allows you to grow or shrink your number of nodes in your cluster dynamically with as little effort as possible. We also have automatic failover. We saw how manual failover takes many steps, but this can happen automatically. You can switch in single primary mode, which is where there's one primary accepting the reads and writes and other secondaries doing only reads. You can switch quite easily automatically. And as we have discussed, sharding is a popular approach, and within MySQL that makes it very popular so you can scale out. Users can use InnoDB cluster to implement a highly available shards in a federated system. Each shard can map to an InnoDB cluster. Here's something to keep in note. Each InnoDB cluster lives in one data center. Because of network latency, it is not recommended to split one InnoDB cluster across data centers. I'll show you later how to achieve high availability among data centers by using InnoDB clusters. All these three use cases give you a highly available distributed MySQL service. So what are the components of the InnoDB cluster? Our first component is group replication, which you can see on the bottom with the two red disks. It coordinates the group of MySQL nodes. The second piece is the MySQL router, and that's on the top, and it provides client connection routing. The third piece is the MySQL shell on the left, which allows a simple setup of an InnoDB cluster with the MySQL shells. All these pieces work together, and I've been testing 8.0.18 during this presentation. We have lots of people using the InnoDB cluster in production mode. One of our large financial customers, headquartered in California, is using the InnoDB cluster to manage millions of transactions. All components work together and they're all built together. The first piece of the MySQL InnoDB cluster is group replication. There's no data loss if a single server node fails. Group replication handles that. The communication API is responsible for handling the communications among the nodes in the cluster. It reports on its status to the other pieces in the cluster. We'll talk in more detail about group replication. Now we're going to talk about the other two pieces of the MySQL InnoDB cluster. The second piece of the MySQL InnoDB cluster in the yellow here is the MySQL router, and they sit on the application servers most normally. The router is a proxy that sits between the application and a replica set. And its primary role is to make any failover process that happens in the replica set transparent to applications. Transparent client connection routing in a stateless design offers easy client routing. It accepts client connections as if it were a MySQL server and forwards network traffic from it to one or more of the MySQL servers. And this is according to user configurable routing rules. When the topology changes, the router adjusts. The third component of the MySQL InnoDB cluster is the MySQL shell here in yellow. This is how we build the cluster. It's an interface to make it easy for you. It's a single client for all administrative and operational tasks within the cluster. We support multiple languages within the MySQL shell: JavaScript, which is the default, Python, and SQL. Within the MySQL shell, you can get the status of all your nodes in one place. You can connect to one node and get the status of the other nodes. Please note that we support the document and relational model within the MySQL shell. As you know, MySQL has now two databases in one, supporting the relational model and the document model. And I've talked about this in other presentations, so you probably know about this. You can actually use SQL on your documents, and you can prototype from the MySQL shell. Now, I've talked about the MySQL shell with a number of customers and a number of presentations. There was one I did last year in Florida, and they were very excited about the MySQL when I finished showing its capabilities. So I hope you will be as well. The MySQL shell is really an admin API. It has many provisioning tools. You can manage your InnoDB clusters. You can create clusters. You can stop clusters. You can dissolve clusters. You can deploy MySQL instances. And then you can stop the instances. You can validate these instances as well. And in a sense, it's really the monitoring tool for your MySQL InnoDB cluster. Here's a drawing that shows what the MySQL InnoDB cluster looks like in single primary mode. Note there was one primary node that gets reads and writes, and you can see the icon there with the pencil and the paper. In this cluster, there are 4 secondary nodes that do reads only, and you can see the sunglasses there. A component called the group replication handles the cluster itself. With the InnoDB cluster, the consistency default is eventual consistency, which is asynchronous replication. Here you see the rear window icon on the right, which means I'm doing exploratory testing. I'm using MySQL 8.0.18 to test the InnoDB cluster. The first thing that I'm doing here, and you can do this on your own as well, is typing MySQL sh, that's the MySQL shell. And we're deploying 3 sandbox instances, each on a different port. The first one is 3310, the second is 3320, and the third node in our cluster is 3330. So that's the first thing you want to do to start doing your exploratory testing. Then we connect to the root at the localhost 3310. We're instantiating the cluster with the create cluster command. You give it a name, in this case test cluster, and the variable we're using is cluster. And then we're adding our second instance with cluster add instance, and we're giving it the second port. You're prompted for the root password, and then you select a recovery method or the method to build the second node. And the default is cloning, and cloning is a really fast way for you to set up another node in the cluster. And then our final command to create the 3 nodes in our cluster is we add another instance at root localhost port 3330. So it's only 7 steps, and we're available now to proceed with the testing of our cluster. So here's another film, and this one is about cloning. It's from a film called Multiplicity. Michael Keaton as Doug plays 4 different versions of himself. He clones himself. So this is another metaphor for the MySQL InnoDB cluster. The cloning process within MySQL InnoDB cluster saves you much time. You don't have to restore from a backup and then sync the logs to make sure that a new node is up to date. Instead of relying on an asynchronous replication to recover the transaction, MySQL clone takes a snapshot of the data on the donor instance, the primary node, and transfers the snapshot to a receiver, in this case, a secondary node. Now we're going to get the status of the newly created MySQL InnoDB cluster. So we type the command cluster status, the function, and we see the name of the cluster, and we see that the primary is on the local host on port 3310. The command also shows us the topology. The node on 3310 is read-write, and it's online. That's our primary node. It shows the secondary node, which is on 3320, and notice it is RO, which is read-only, and it is online. And it shows the third node in our cluster, which is read-only, also online. And notice it shows the topology, which is single primary mode. So the router, the MySql router communicating to this cluster can direct writes to the read-write node and reads to the other two read-only members. I'm going to show you how to run SQL commands from the MySql shell. First thing you do is type MySQL sh to enter the shell. Then we're going to / connect to the local host with root at 3310. Then we say /SQL. And now you're in the SQL mode. You can see that here. And then we say show databases. And I have one database here that I've clipped. Just to give you an idea how it works. Database X. So the default mode in the MySQL shell is JavaScript, but you can switch to SQL mode and also Python mode. Now I'm going to show you how the default behavior with the InnoDB cluster in single primary mode is eventual consistency. We're going to run two transactions. We're connecting to node 1 on port 3310. T2, table T2 is empty, and we're going to insert into T2 select star from T1. If we select count star from T2, we'll see that we have about 150,000 rows that have been committed. Now we're going to go to the second node, which is port 3320, and we're going to see the count. And notice select count star from T2, it has 0 rows. And that's because the communication between the nodes is asynchronous. So we're getting a stale read here. Here we see a loaf of stale bread, and that's a metaphor for a stale read. In my little application here, I didn't want stale reads on secondaries. Reads on secondaries are a win for scalability, but we have the possibility of stale reads that occur when any application reads from a secondary before that secondary has received the updates that have been committed on the primary. A user may want to update rows on a primary and then want to read the updates on the secondary, but sees stale data. We don't want that. It's a race condition that operates over low latency connections. It can keep secondaries trailing their primaries very closely. But as software engineers interested in building bulletproof systems, very closely isn't good enough. We can do better. Let's take a look at a technique to make sure that stale reads do not occur in an InnoDB cluster. We're going to change the default setting to avoid stale reads. We're on port 3320, which is one of our secondary nodes. We're going to use the command set session group replication consistency equals before. This mode is set on each secondary to ensure that the data read on each member with group replication consistency set to before won't read data until the data has been committed. The wait could be long, and there is a timeout to avoid that. We'll talk about that later. I'm setting it in a session level, but you can also set it on a global level. So let's check to see if it's set. So we show variable like group replication consistency, and we can see it set to before. So before I do a read, I'm going to wait for the update. Now we'll see how we don't see a stale read on a secondary node. The same scenario as we did before. The first node on port 3310, we insert into T2, select star from T1. This time we go to node 2, port 3320. We select count star from T2. And this time we see a wait with the before consistency setting. And then we see after the transaction has been sent over to node 2, we see the answer, which is 150,000 rows. Now we come to the big discovery coming next. Through exploratory testing, I have learned something new. My big discovery was setting the before consistency setting also includes before on primary failover setting. The before on primary failover setting ensures that if and when automatic failover occurs, the process allows the node to read and commit any pending transactions before accepting new transactions. I had wanted to set both of these, but I couldn't figure out how to do both. So I contacted the author of one of the blogs that I will point to later about my dilemma, how I couldn't set both. And he told me that setting the before on a secondary node also sets the before on primary failover, which is an important setting for your InnoDB cluster. Again, this is my big discovery. I'm repeating myself just to make it clear. The before consistency setting also includes the before on primary failover. I would have never determined this without doing exploratory testing. This is showing how failover will work. We have the MySql router, and it's directing the read writes to the primary and reads to the secondaries. So here we see the crash. We see that the router is knowing that it doesn't connect anymore. A new primary is selected. So we can continue. If a single node fails, it's okay. If an online node stops responding to the other nodes because it has crashed, there might be networking problems, its state will be switched to unreachable. If the unreachable node doesn't return before the timeout, it will be removed from the group by the remaining nodes and thus will appear as missing in the cluster when you look at your cluster output. Using the MySql shell, we can see a node that has left the group. So we type cluster status, our function, and we see the topology, and we can see that the 3310 is read write, our primary is online, and we can see the second node is read only, but we can see that its status is missing. Now, to have this happen, I stopped the MySql instance on the node 3320, port 3320. Okay, we've seen what happens when a node goes offline. But what about a node that wants to join the group? So we can see the node in white over here. It wants to join the group. So a node that joins the group will synchronize with the others. It will fetch the missing data from a node in the group. During this period, it is in a recovering state. And you can see the node on the right that's trying to join the group is now listed as recovered. While this node that's coming online is recovering, we can type the cluster status again, and we can see that the node 1, which is on port 3310, is online and it's read write. And we see the second node, and we can see it is read write, but it's recovering. So you can see what's going on with your cluster from the MySql shell. After a node is synchronized with the group, it's considered online. The node or member only becomes online after it has read all the pending transactions. Requirements by design. In the InnoDB cluster, every table must have a primary key. You can create a table without a primary key, but when you insert into the table, you will get an error. We also require global transaction identifiers, GTIDs, to be turned on. A global transaction identifier, GTID, is a unique identifier created and associated with each transaction committed on the server of origin, in this case, the primary node. The identifier is unique not only to the server on which it originated, but is unique also across servers in a given replication setup. You must have the binary log turned on, and it requires a binary log row format. The binary log row format records every change or event to the database. And I should mention security is built in. the InnoDB cluster supports encrypted communication channels through group communications. The last thing I wanted to mention is that up to 7 server nodes members can be in the group. You can replicate from one InnoDB cluster to another InnoDB cluster in 2 data centers. This is important for a disaster recovery plan. Many of our customers run at least 2 InnoDB clusters in 2 different data centers at different locations. So the way you do that, you have the 2 InnoDB clusters at 2 data centers, and then you have one cluster talking to another cluster, like a backup cluster in a different location. So this gives you even more high availability in case of a disaster. We've seen how the InnoDB cluster works with automatic failover in the single primary mode. Now we're going to talk about the InnoDB cluster with multi-master replication. What is the InnoDB cluster in multiple primary mode? We provide this extra functionality. We automatically detect and handle locking conflicts between the nodes in the cluster, and we also provide increased distributed fault tolerance. With the multiple primary configuration, we solve the problem that it might be a problem in a single write-only node. It makes it a single point of contention. Writing to the entire group may prove more scalable under certain circumstances. So in this multiple primary configuration, there's no more failover. All the members or nodes may accept reads and writes. We do the majority consensus of transactions, which I'll talk about. The first committer wins write stability. The first thing we note here is that all of the nodes are read-write. See the pencil with the paper? We have the same configuration in terms of we have the MySql router and the MySql shell that talks to the cluster. But this time, all of the nodes are read-write. MySql group replication uses Paxos for its consensus algorithm. It's a theory developed by Leslie Lamport, and he describes this theory in a paper called The Part-Time Parliament, and here's a link for that. In this paper, he describes how archaeological discoveries in ancient Greece on the island of Paxos perhaps revealed that a government functioned despite that its legislators were part-time workers. They were business people, and sometimes they would leave a meeting and try to set up a business on another island. The Paxos Parliament protocol that Lamport describes, it provides a new way of implementing a state machine approach to the design of distributed systems. The group communication system built by the MySql team is a variant of Paxos developed right here in MySql. And it's a building block to provide distributed agreement between servers or nodes. As shown in the drawing above, a simple majority would determine the fate of a bill in ancient Greece. That's why Leslie Lamport named his consensus algorithm Paxos. The goal of the Paxos algorithm that Lamport wrote is for some number of peers to reach agreement on a value. In his theory, Paxos guarantees that if one peer believes some value has been agreed upon by a majority, the majority will never agree on a different number coming across or transaction. The protocol is designed so that any agreement or consensus but must be made by a majority of nodes. In this case, we see this meeting of legislatures and there's some empty seats. So it's mimicking this. They can have a vote, the majority agrees, so the bill would pass. In comparison to 2PC, it requires more messages, but is more resilient to coordinator failures. 2PC is two-phase commit. Leslie Lamport published his paper in 1989, and he was given the coveted Turing Award in 2013 for his work on distributed systems. With the InnoDB cluster in multi-primary mode, updates can occur from any node. In this case, we're going to see two transactions setting two different rows to a different value. It's true that any two transactions on different nodes can write to the same row, but in this case, they're writing to different rows. So on the left, we're writing to the table T1, we're setting column 1 equals 3, where column 1 equals 1, and we're updating table T1 on the right, setting column C1 to 4, where column C1 equals 2. There is no conflict. Both updates are committed. Both are okay. In this example, we're going to set the same row to the same value. Any two transactions can have this happen, but conflicts will be detected and dealt with. The first committer wins rule. So on the left, we're setting rows C1 equals 1 to 3, and on the right, we're setting column C1 equals 1 to 4. So that's a conflict. In this case, we have a conflict. So what happens? The row that is updated to C4, that update transaction happens first, and it commits. The second transaction aborts because there's a conflict. We're trying to set the same row. So the first committer wins. There are other things that you should be aware of using the multi-primary cluster. There's no global lock manager in a multi-primary cluster. A global lock manager would slow things down. We do optimistic locking with the InnoDB cluster in multi-primary mode. So there's some operations to be careful about. But the lack of a global lock manager makes operations such as cascading foreign keys and for share update tricky. Both could resolve in undetected conflicts. There are settings to deal with this issue, but it's more simple to avoid these operations if possible. And concurrent DDL, data definition language, such as create table and alter table, these operations can be dangerous in any multi-master cluster. And global DDL, objects that exist outside of one database, such as the creation of users, can also be deadly. Imagine nodes crashing in the middle of concurrent DDL or global DDL. And it's not just the InnoDB cluster in this mode that is dangerous. I've tested at least 2 other multi-master systems that had the same issue. Our last section is on good things to read. There are many good blogs written about the InnoDB cluster, and I'm going to point you to some of those. The first blog listed here is how to set up an InnoDB cluster. This blog does not tell you how to set up a sandbox instance, but it will tell you how to send it up using real nodes within a system. The second blog is talking about consistency levels within the InnoDB cluster. If you don't want eventual consistency, you can read about this. Another article to read is setting up the MySql router. I didn't talk about setting that up, but this article at dev.mysql.com will tell you how to set up the MySql router with a sandbox image. There's another article about read consistency within the InnoDB cluster that I recommend, and that's at the link mysqlhighavailability.com. There's a deeper dive on read consistency as well. Here are the same 2 links that I just showed you. This is the last link I'm going to show you. It's on best practices, and it goes into great detail on lots of settings that would really be advantageous for you. We're coming near the end of the talk, and I want to make a couple of recommendations. Do some exploratory testing to help form your high availability strategy. Set up a sandbox instance with the default single primary mode, and then do some updates from the primary. Do selects on the secondary. Try the setting that prevents stale reads on the secondary nodes. in the cluster with the set session dot group replication consistency equals before, and then do some updates from the primary to see what happens when you do selects from the secondary. You should see a wait before you see the row. Note that the default timeout period for a read operation on the secondaries could be long, and you can modify it to be a shorter time with the set wait timeout to a certain number of seconds. So here's some final thoughts. The MySql InnoDB cluster might be a great choice for you. First, test the InnoDB cluster in single primary mode. If you want to test failover, stop the primary node and watch how the MySql router switches to a new primary node or member in the cluster. I've tested automatic failover and it works. After you finish your testing of the InnoDB cluster in primary mode, you may want to leave the default consistency of eventual on the secondaries. But as a default setting for your environment, you should probably set the group replication consistency equals before on primary failover on all secondaries to force the new primary after failover to read pending transactions before accepting new transactions. Here is an editorial. The before on primary failover setting should be the default setting for the secondaries in an InnoDB cluster running in single primary mode. You may want to set your MySql InnoDB cluster to multi-primary to do more exploratory testing. You can take an existing InnoDB cluster in single primary mode and turn it into an InnoDB cluster with multi-primary mode. You can do that from the MySql shell. Thank you for your time during this session, and I'll now leave it for questions. You can type your questions in the Q&A box, and I'll leave this running for about 5 minutes so that you can ask questions. Thanks again for your attention.